All right, I'm going to show you the Chapter 9 series tests. If you remember, we learned a lot of different tests, the parting C's, but they've told us which ones are not on the test, so we can hopefully assume these other ones are on the test. They said no telescoping, integral, nth term, comparison tests. Okay, good. So we do have to do the P series, pretty simple. Alternating series, also pretty simple. Ratio test, probably the most important one, and takes a little time. And then a really simple geometric series. So we got three of the four of some of the easiest tests. So let's see what we got here. Remember the P series test is just your basic some number over n to a power. If you remember we talked in class, that gap has to be more than 1. So what the P series is saying is if the exponent P is greater than 1, in other words, it's more than 1 bigger than that top, then it converges. If it's exactly 1 or less, it diverges. So example, that's exactly 1. That's our divergent. It has a name called the harmonic series. He's divergent. If we go 0.9, he's less than 1, definitely divergent. And if we just beat 1.1, that's convergent. So, 1 over n squared is convergent. So again, that's all P series says, pretty simple. Now let's jump to alternating series real quick. If you have a -1 to the n or -1 to the n plus 1, it's now an alternating series. An alternating series, the gap doesn't have to be 1, it just has to have a gap. It could be 0.2, it doesn't matter. So this is now a convergent series, as long as there's a gap. So 1 over n, even if it's 0.9, still convergent. So that's all we have to do. If they tie, or the top is bigger, remember it failed, and that was the nth term test, which they're saying we don't have to know. So alternating tests only prove convergence. So either it's convergent, if the top is bigger or they tie, then we say it diverges by nth term tests, which supposedly they're not going to ask, so I don't know. I'd be familiar with that one just in case. But alternating series test, you just have to have a gap. So let's compare again these two. P series, your gap has to be more than 1, not 1, more than 1. All right. Now this gap helped us a lot with the comparison test, which we don't have to do. All right. All right, let's jump to the geometric series test. You can have some number, some ratio to the nth power. Whatever's to the nth power is your ratio. Your ratio has to be less than 1 to be convergent. If you thought that through, when your ratio is less than 1, the terms are getting smaller as you go. So you want your terms to get smaller. So to have a sum and to be convergent. If your ratio is 1 or more, then every term is getting bigger, 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 and adding up to, and the sum would be infinity, and so it is a divergent series. So really, that's pretty simple series to look at. You just have to look at the ratio and go, hey, is it less than 1? It's convergent. So remember, if it is convergent, so let's say we're convergent, remember the sum is the first term over 1 minus the ratio. So if they had you find the sum of the convergent series, so let's go ahead and throw in a 5 2/3 of the n. So let's start this at 0. We can start at 1 also, but let's say it started at 0. If I plug in 0, that's gone, but I got 5. So my first term is 5 over 1 minus my ratio. Well, ratio is 2/3. So 5 over 1 minus 2/3 is a sum of 15. So that one is convergent because it has a sum, which is 15. All right. So again, geometric series, ratio has to be less than 1. Where they try to trick you with this is in your multiple choice. They want to see if you guys know the difference between like e and pi. Something like that, or a trig function. So for example, e is 2.728, pi is 3.14. So we have a fraction less than 1. So this is a convergent series. So maybe they put sine of 1 to see if they can confuse you. Remember, sines only goes between 1 and minus 1. So this is no more than 1. Again, this is convergent series. If they flip those, divergent series. So that's where they're going to try to get you. They're going to sometimes, you know, geometric series. Otherwise, it's such a easy test. Okay. All right. Let me erase this and put the ratio test. So the ratio test is when we have like a mix of stuff. So let's say I got some problems here. So I got an exponential equation mixed with a factorial equation. Those are different kinds. So this is when ratio test comes in. Now remember, factorial is a beast, and he's gonna win this battle. So this is gonna be a convergent series. We'll find out. But let's go ahead and go through the ratio test. So you take the limit. Remember, it's of absolute value. Now, so that'll get rid of the alternating series, which is nice. So that'll go away. So remember, it's the next term. Now you're going to divide. It's the next term divided by your series. Now, dividing by fraction, we just take a little shortcut, and we multiply by the reciprocal. So think that through is, we're going to take the next term. That's what this is. When I add 1, I get the next term. So I'm taking term 2 over term 1, let's say. Well, to be convergent, we want the numbers getting smaller. So we have to have a limit here less than 1. So that's why this series is, hey, if it's less than 1, it's convergent. If it's greater than 1, it diverges. And if you get exactly 1, the test fails. Usually you get test fails doing ratio when you misuse it, when you use it on a problem that wasn't supposed to be done by ratio test. All right, so we take this limit. So we clean up. We can cancel out the 2 to the n and 2 to the n plus 1, get a 2. N factorial cancels with n plus 1 factorial. Went over that many times in class, n plus 1. As I'm approaching infinity, I get 0. So as you can see, my ratio is less than 1, or my limit is less than 1, so this converges. So we'd say it converges by ratio test. All right, I'm going to show you one that diverges. Sorry for all the squeaking. All right, and we got, let's see. So again, I got a mixture. I got some exponential equations, but I also have a mix of polynomials. So I got a mix of stuff. This is where ratio test comes in. If I didn't have that and squared, I could have done the geometric series test. All right, so limit. And we add 1 to each term. So I got to add 1 to the n, so I get n plus 1 squared. 2 to the, I'm putting n plus 1 plus 1, so n plus 2. 3 to the n plus 1. Don't forget the absolute value. Again, we're supposed to take that next term divided by r's, but we're multiplying reciprocal. All right. So these 2's cancel to be a 2 on top. The 3's cancel to be a 3 on the bottom. And then I was thinking it was going to be a divergent, but it's not. So we got the powers the same. We take the limit. We get 2/3. So this one is also less than 1. I guess this one also was converges. So if I just switched the 3 and the 2, you would have had those switched, and we would have had greater than 1. It would have been a divergent series, but still the same test. So all you have to do is look and go, if it's less than 1, as we've done 2 of those, it's convergent. If it's greater than 1, then we'll get a divergent series. All right, so those are the tests that we have to know. I can see those being that first 25-point question, maybe asking a couple of those.